Well, hello, retro computing enthusiasts, electronics nerds. Mike here. Welcome back to my channel. Today, I thought I would give you a look at my small collection of three microcomputer trainers that I have. These things are just a whole lot of fun, and they bring a lot of nostalgia with them back to the early days of the microprocessor revolution. And I just love these things. I play with them a lot, at least as much as I have time to play with them these days, and I have plans for all of them for the future. I've got a Heathkit ET3400 over here. I've got an Intel SDK 85 right here, and over here a Southern Cross Z80. They're from different eras. The ET3400 is 1977. I found conflicting info on the dates for when the SDK 85 was originally released. But the manual that I found for it online has a copyright date of 1978. So we'll go with that. Now, the Southern Cross over here is not a vintage design. This is sort of a recreation of what trainers of the past were like from about the 1992 era right here. But it's a whole lot of fun. And if it had been around back in the day, I'm sure it would have been very popular. Okay, so I'm going to show you each of these in depth individually, talk about them a little bit, how I got them, what features they have that I really like, and what my plans for them in the future are. So let's start with the ET3400 over here. So here we have the Heathkit ET3400 microprocessor, or microcomputer learning system as they call it. I call these things microprocessor trainers. These were all the rage back in the 1970s, and they were much more affordable than full-blown computer systems. The up-and-coming computer engineers and technicians in schools could learn about them with these. These were very popular in schools and colleges. And in fact, I talked about the nostalgia factor attached to these. I actually used one of these in high school. I've talked about this before, how the high school I went to in Michigan was located very close to the Heath plant at Benton Harbor. And Heath had donated a whole lot of equipment to the school I went to, including some of these. So I used some of these in high school. Now, I'm not going to go too great in depth on the ET3400 here because I already have a series of 4 videos covering my purchase of the original broken unit and restoring it. It had no back, parts were hanging out. I bought another type of Heathkit trainer that had the same kind of back on it, got it cheap, and did a back replacement on it and got it all up and running again. And I have a grand old time with this. And I have some plans for this for the future. I purchased the ETA 3400 reproduction kit that Scott Baker sells. The ETA 3400 originally sold by Heathkit will give the 3400 here extra RAM, ROM, and I/O capabilities, as well as speeding up the clock speed of the processor. It would include a serial port, cassette interface, and other goodies. And I bought the reproduction that Scott Baker makes, and that may be a retirement project. I just have not had a chance to get around to implementing it yet. So someday I will put it together and attach it to this, and we'll have a much more functional computer than we have here. But I'll put a link in the upper right to the videos on my original purchase of the ET3400 and all of the work I went to cleaning it up, putting it back together, and getting it up and running and playing around with it. So you can check that out if you like. But yes, in the future, I have future plans for my beloved ET3400. And here we have the SDK 85. I absolutely love this. This is a lot of fun to play around with. I just have all kinds of fun with it. It's so easy to program. I'm pretty good at Z80 assembly language, but I haven't had that much experience with 8080 or 8085 assembly language. So this has helped me pick that up a lot, writing little programs for this. Now, this computer I bought on eBay, and clearly it is a former Foothill College electronics computer. Um, SDK2 or I don't know, or 11, I don't know. But yeah, Foothill College, no idea where Foothill College is. But thank you, Foothill College, for selling your surplus so that I could buy it. So somebody, I don't know if it was students or what, has put in some stuff over here. This is the SCK85. This is a little single board computer trainer with a keypad and 7-segment displays. That's the whole thing. Somebody has mounted it in the case with a power supply, which is very nice, very convenient. I don't know if it's the college or one of the students who did it. And another convenient thing is they have wired in the bottom of the board, it's all wire wrapped. I've had the board out. They have wired in a couple of the I/O ports from the computer over here. So we've got dip switch for input and we've got LED lights for output. And I'll demonstrate a little program I wrote to take advantage of that later. But that's very convenient right there. And they also brought out the those two ports right here on these headers so that they could be used over here on the solderless breadboard, which is also an addition that this board did not come with. So this board uses the Intel 8085 microprocessor here, and this is what Intel called a system design kit. That's what SDK stands for. Every time they released a new processor back in the day, they would release a system design kit for computer system designers to learn the ins and outs of the new processors, like the 8085, which was fairly new back when this came out. And then they could design those processors into their systems. They had put one out for the 8080 originally. The 8080 took off and was one of the things that really ignited the microprocessor revolution. So they put one out for the 8085 when it came out. They put one out for the 8086, and so on. I'm not sure at what point they stopped with the system design kits, if they ever have. I don't know. Maybe they're still doing it for chips these days. Who knows? But I imagine they stopped it at some point because the chips have gotten so complicated, and there's no point trying to program them with a little numeric keypad and a 7-segment display. So anyway, I got lucky with this. Number one, it works. Now, when it first arrived, it had a couple of issues. I got nothing but gibberish on the 7-segment displays, and it would not reset and clear. And a little poking around, I realized that the 8355 chip here was not seated properly in its socket. And this has the EEPROM in it for the monitor program that's running. So once I reseated this chip, everything worked. This little red bezel had fallen off of the 7-segment displays, and I lost it for a while. And I was going to make something new, but I just recently found it as I was preparing to make this video. So I will glue that back in place because it makes the display much more readable, especially if there's a lot of ambient light. So I'm going to put that back on. But yeah, this is a whole lot of fun. It's a very capable little computer. It's got a whole lot of I/O ports. Not much RAM. 512 bytes of RAM. That's 512 bytes, not 512K, not 512 meg, not 512 gig. We're talking 512 bytes of RAM. Okay, that's it. But um, that's enough for a lot of simple training programs. Now, I do have plans to expand this. I was lucky in that this board is fully populated. A lot of these boards come, this section up here is optional. You don't have to populate it to get this to work. What this is decoding and buffering of the CPU signals so that you can expand easily without loading down the CPU. So what I can do over here is I can add extra RAM, extra ROM, maybe even a UART for serial I/O. Although, when we talk about the Southern Cross, there's an alternative. The Southern Cross has serial I/O, but it bit bangs it out one of its parallel ports, and I've got potentially 10 parallel ports here, so I've got plenty of ports for bit banging serial I/O out. Now, speaking of serial I/O, this thing will actually do serial I/O according to the manual. Now, it is set up via this circuitry here for a 20 milliamp current loop to a teletype, which was how you did serial I/O back in the 70s. They didn't have a lot of smart or even dumb terminals back then, or what they call glass teletypes. You actually had physical teletypes. And you can do serial I/O using special instructions in the 8085 at a blistering 110 baud to a teletype on this. Now, I could modify it to send it out to an RS-232 dongle, but I think I can do better than 110 baud by bit banging on one of the parallel ports, or I might just put a UART in the expansion area over here. Anyway, we'll see. I do have some plans for this. I don't know how far I want to take it because I have other single board computers based on the 8085 chip. I would like to use this to develop some programs for them, but I don't necessarily need to pimp this out as nice as they are. You know what I mean? I just need to develop good enough software to where I can bootstrap up the other boards and then continue developing on them. So really, I'm not sure exactly how far I will take the expansion on this, although I would definitely like to have some extra EEPROM space for programs that aren't going to go away when I turn the power off. And I could get that by putting in an 8755 chip here, and I'd get 2 more parallel ports out of the deal too, as well as 2K of EEPROM. But that chip is kind of hard to find and very difficult to program. So I'm thinking an external EEPROM or EEPROM would be a better option for this. So that's probably the way I'm going to go. Anyway, let me type in a little simple program I wrote, and I'll show you what this computer can do as it sits. So this little program I'm going to type in is just a little counter program. It's going to count in binary from 0 to 255 and recycle. And it's going to display it on the 8 LEDs up here on the I/O port, as well as displaying it on the 2 7-segment displays over here for the data. So it's going to take me a minute or two to type this in, and then once it's in, we'll run it, okay? And it's a little hard for me to type from this angle, so this might take a little while. But as I type in, I'm starting at memory address 2000 hex, and as I type each byte into memory, I hit next, and it saves it into memory and then goes to the next address, which is nice. I don't have to do too much to type stuff in. It's pretty simple. And pretty idiot proof as long as I pay attention to what I'm doing and not too much attention to the camera. So I think I'll stop and finish typing this all in and review it, and then I'll show you the program in action. All right, I have finished typing in the program. I'm just sort of reviewing it now to make sure I have not made any typos or fat finger errors, but it looks like it's pretty darn good. All right, so let's reset it, and we will go to location 2000 hex, and we will execute. And look at that, we are counting in hexadecimal over here. We're counting up, and over here in binary, you can see the LEDs over there counting up in binary. So I'm sending the count as it happens, out both one of the parallel ports to be displayed on this bank of 8 LEDs, and there's actually a built-in routine in the monitor for displaying byte data on the data display here. These two 7-segment displays here are for data information. So I'm using that monitor routine to display it down here, and then just outputting it to the port up here to be displayed on the LEDs. So that's kind of cool. It's a start anyway. This was the first program I wrote in 8080 assembly language. So, assembled it, compiled it, and it works. I had to do a little tweaking on it. The count was going by too fast to read, so I tweaked it so that it was a little slower, so you can actually see the individual digits, and the lights don't sort of blend together up here. But yeah, it works. And I've been working on some other programs for this, and that's going to tie into my expansion ideas for this for the future, I think. I'm just having all kinds of fun with my SDK 85 here. It's one of my newer acquisitions. I've had the ET3400 for a couple of years now. This is like one of the shiny new things, so it gets more love from me right now. And the next thing we're going to look at is the Southern Cross Z80 trainer. And that is really a shiny new thing because that is my newest trainer of all. So let me get it up here on the bench and show it to you and talk about some of its virtues. So here is the Southern Cross Z80 microprocessor trainer, single board computer. This is a much more modern take on the traditional computer trainer. It's got a lot of the same features, but it's built with much more modern components. I mean, including a blue LED. There were no blue LEDs back in the day. You were lucky if you got amber or green back in the day. Red was the original color for LEDs. We do have the traditional 4 7-segment displays for address and 2 for data, and the numeric keypad, 0 through 9, A through F, and a few function keys. Got a reset button. Z80 microprocessor. I do really like the fact that the EEPROM is in a 0 insertion 4 socket. It makes it easy to take it out and put in your own custom firmware. Also, there's a lot of space left on this. We have 8K of ROM space here, but the monitor running on this only takes up 2K. So there's a lot of room in there for custom programs that I could put in. So yeah, with 8K of ROM, we've got plenty of space for custom code in there. We have 8K of RAM, which is a whole lot more than the SDK 85, which I just showed you. What is that, 16 times as much? So that's enough RAM for some serious programming work. As for getting programs in and out of the Southern Cross, there's also a lot of stuff in ROM already. There's a fair number of programs in ROM that you can run. There's a couple of songs you can play that are in ROM. It has a little speaker right here. It makes sound. And also there's a guess the number game in the ROM, guess the hexadecimal number game, which adds a little bit of an extra twist to the game. But that's kind of nice that it comes with some built-in programs. In fact, let's listen to one of the tunes. So if I press the function key and then the 8 key, there we go. Can you hear that? There's a couple of different tunes built into it. It's kind of cool. And like I said, there's the guess the number game. But what makes this trainer computer a little more useful than the other two I've showed you is that the monitor in this one will connect via a serial port to a terminal or a terminal emulator that we would use in modern times. And that makes this a whole lot more useful because you can send programs into it and save programs out of it that way without any extra hardware. So I mentioned when I was talking about the SDK 85 about its slow 110 baud rate. Well, The Southern Cross here bit bangs serial out one of its parallel ports at 4800 baud, or a whole lot faster than the SDK85. In fact, that is not the speed limit for this. That's just the default setting. I could actually increase it. And this particular Southern Cross computer, I was very lucky. It came with a USB to 5-volt serial adapter. So I could just plug this into one of my laptops, fire up a terminal emulator, and talk to the Southern Cross. In fact, we'll do that in a bit. But I also got lucky with this because the Southern Cross generally comes as a bare circuit board that you have to populate yourself. You've got to find all the components. And since this is a design from the 90s, it can be getting a little hard to find some of these components. But I found this one already fully built and tested on eBay. And not only that, the former owner had a nice 3D printed little case for it here. So it's not just a bare board sitting up here on my bench. It actually has a 3D printed case on it. And I saw this on eBay and I hemmed and hawed about it. I'm like, well, I don't know. I've got a lot of Z80 computers. I'm kind of a Z80 aficionado and fan. I'm like, do I really need another one? Well, I don't have a Z80 trainer, yada, yada, yada. And I was watching the auction for this, and there didn't seem to be any interest in it. The starting bid was quite low, and I thought very reasonable, and nobody was bidding. So as the auction ticked down to the last few hours and few minutes, I thought, well, I'll throw the minimum bid out there, and if I get it, I get it. If I don't, I don't. Well, I was the only bidder. I got this really cheap, and I'm pretty darn happy with it so far. And it has a full expansion port over here. All of the processor signals are brought out. So that's nice. So that makes expanding this little computer easy. Also, there's already a lot of address decoding done that comes out on this header over here. So if I wanted to add, say, extra EEPROM or extra RAM, it's pretty easy. In fact, the Southern Cross can be expanded fairly easy up to 56K of RAM, which is not too shabby. You could probably get CPM up and running on this thing if you really wanted to, although I'm not sure you really want to on a system like this, though. With its ability to talk to a terminal, that would really work great. So that's a possibility for the future. Speaking of talking to a terminal, let me get this plugged into one of my laptops and I'll show you what that looks like. Okay, so I have the Southern Cross hooked up to one of my laptops. I've got TerraTerm opened up in a window here. And if we reset the Southern Cross and press the function key twice, look at this. We get the Southern Cross on-screen monitor program here, serial monitor 1.8. Again, this is being bit banged out of one of the Southern Cross's parallel ports. It has no serial I/O chip in it, no UART. So 4800 baud, that's pretty good. And as I think I said earlier, that is not the speed limit. That's just the default setting. So let's have a look at the commands here. So we can display data, we can modify data, we can toggle single stepper, we can go from an address, basically run a program at an address, and we can download an Intel hex file, which is nice. That's going to be very useful in the future for getting other programs into the Southern Cross. But let's exercise this a little bit. Let's do D0000. We'll look at what the contents of the EEPROM down in low memory are. So we can take a look at that. Yeah. Nice little feature. Escape. Let's have a look at the other commands here. Go from an address. So we could go G0000 and restart the Southern Cross. And it just restarted. So I'm going to have to bring the monitor back up again. But that's easy enough. So Yeah, this is very cool. I really like these features of the Southern Cross. Is there anything I don't like about the Southern Cross? That blue LED is just annoyingly bright. My goodness, it's bright. It does not lend itself very well to filming, so that is kind of annoying. I guess some people don't like the beep, so there is a way to turn it off in the monitor. People who don't like the beep, it doesn't bother me really. What other features does this have? There are some modifications you can make to this. I talked about upping this to 56K of RAM. You can also put in a battery-backed RAM socket, or I assume just a Dallas battery-backed RAM itself, with a clock calendar in it. And this has functions in the monitor for reading the clock calendar from either the battery-backed socket or, I would assume, the Dallas battery-backed chip. So that's very cool. So you can so your programs would not go away every time you turn the power off. That would be great. And also having clock calendar in here would be very helpful too. Although we're getting beyond just a bare bones trainer where you would learn bare metal Z80 programming and getting into something a little bit more sophisticated. But I guess there's nothing wrong with that. You can work your way up, sort of bootstrap yourself from a very low level up to something more significant. And I think I said earlier, if I really wanted to, I could probably get CPM running on this thing. Although I think that's kind of overkill. I have a lot of other Z80 computers I can run CPM on. So this is more for fun and keeping myself current with programming the Z80 at a bare metal level. So that's kind of cool. In fact, this is what all of the trainers are for: programming your microprocessors basically at the bare metal level, nothing between you and the processor. So you're learning how to be like God manipulating the hardware. You have absolute power over it with these, and you learn everything at a very low level before all the different abstraction layers that get put on top of it with operating systems and programs and whatnot. So it gives you a very deep understanding of the system at a bare metal level, and that's really what all these trainers are for. So I'm not really sure how much I want to pip them out into complete systems. I'll give it some thought, although it's a nice exercise to do it. And you can always strip all the bells and whistles off and go back to the bare bones system if you want to, and keep your skills current with programming at the bare metal level. So there's my 3 trainers. Do I have plans to buy more? Well, I would love to have a couple of others. I would love to have a Kim 1. Um, Working Kim 1s, though, number one, they're rare. And number two, they're very expensive. Very, very expensive. So I may or may not ever have a Kim 1. I would like to have one. I played around with one of those in high school, too. Um, Next choice would be a Sim 1, which is a Kim 1 clone, which is a little more common and a lot less expensive. So that's a possibility down the road, too. And there are other computers out there. There's several other Intel SDKs that I might be interested in, like the one for the 8086, possibly. Thinking about that. We'll see if a reasonably priced one comes along. That would be great. And who knows? There's all kinds of interesting stuff that comes up for sale on eBay and other places. I wasn't looking for the Southern Cross when I found it. Who knows what I might find in the future? Well, there you go. There's a tour of my 3 microprocessor trainers and kind of what my plans for the future with them are. That's fluid. It might change, but subscribe. You might see future videos where these show up with various modifications in the future. So subscribe. And if you found this video at all interesting, educational, informative, inspirational, whatever, give it a like, give it a thumbs up. I'll see you in the next video. Thanks a lot for watching this one. Bye.